Hello, welcome. In this video, we're going to start off by building the procedural train tool. So in Houdini, one of the first things that we want to do with this tool is we want to load in our modular assets. So this tool is heavily based on using a modular asset, and then based on a certain formula or structure, I'm going to place those next to each other. So we're going to create a geometry network. This is where we're going to build our tool. And what we want to do here is we want to use a file node to load in our geometry. So by default, it will just be a cube. So we're going to put in the path. So here is an example of my model. So this is from the SkyTrain. So you can see it's just a modular part that I can, for example, copy next to each other, and it will nicely fit with those. Now, if you're working with a team of artists or other people, then what can happen is that this is built, for example, in another software. So we're going to have to make sure the scaling units is actually a bit more to our Houdini space. So I'm going to actually downscale this or transform this by 100 units. So we're going to divide this by 100, so 0.01. And this will actually bring it to better spacing for our Houdini world. So I would just often use this. It's pretty easy to then scale up as well. Another thing is then also matching or aligning this geometry. So we can use the match size node. And in this node, as you can see, it will actually center the geometry. In this case, I don't want to center the y-axis. Because otherwise it would conflict with my other pieces. Like I have other modular kits and they might have like a little change in the y-axis because by default it's modeled in a way that they perfectly work. But in the x and z-axis, I just want to make sure it's in the middle, just to double check that. And then the last part, what I want to do here is I want to create an attribute and I want to give this a specific naming. We can give this the name piece. And this is, for example, piece, for example, A or B. So we're going to change this to string. This is called piece A. We can call this piece B and so on. This is what I will do for every modular model. And I will just skip to when I have set up all of these properties. And as you can see, now I have all of them. So in this case, I had 5 of them, which is pretty easy to just quickly do them. If you're really dealing with a bunch of data and a bunch of assets, then of course you might want to build some tools to handle some of these things. But if it's only 5 models, then just build it more yourself. So again, each of them had that process. So each of them have a specific name. So we have A, B, C, D, E, and in this case, I have alphabetic order. You could give this very specific naming or numbers, but my tool or system will work with just either A, B, C, D, and things like that. So will work in that way. So next, what I'm going to do is I'm already going to make a digital asset. So what I usually do is I try to make my base system, then I do a digital asset, and then from there I start to polish up things more. At this stage, since we are working with a multi-parameter, I want to already make a digital asset so I can have that multi-parameter data. So we're going to just select everything that we have. We're going to just, for example, click subnetwork, right click, make digital asset, and I'm just going to call this tutorial 3. So what we're going to do in our menu is we're going to immediately go to parameters, make a folder. And in this folder, we can, for example, name this the number of different wagons the train has. So this will be the amount of different wagons the train is or how long the train is. And we're going to change this to a multi-parameter list. So once we have that, we then now want for each part of the train, we want to define what are the modular models to use. And that is done by a string value. So we're going to grab the string parameter and we can call this, for example, just pattern. Also going to here call this pattern and this an underscore and then press apply. So there will be automatically a hashtag added for the multi-parameter. So we're going to just hit accept and we're going to just add plus icons. So what will happen now is that we can add patterns. So these patterns are basically then referencing to my modular assets. So we have called this A, B, C, and D, and so on. So now I can call this here as well. So we can call this A, then place, for example, 2 times model B, place model C, place model D, so on. So we can use these code blocks here to build something like so. This is just for previewing now. So now I want to build a system that loops over the pattern and then sort of like reads the pattern or splits the pattern into different pieces and then places the modules in peace. So let's start with that. So we already have our models. So again, they all have the numbers and we need to get the right data here now. So I'm going to start out with an add node and we're going to go with one single point. So over this one single point, I want to do a loop. And for each loop, I want to get the data of the pattern here. So we'll try to subtract these patterns into attributes. So we're going to go here and we're going to say for each number. So this is a loop that is based on this number, iteration number. So we will loop now 10 times. So we don't want to loop 10 times. We want to loop based on our wagon number, which is actually called folder 0. So the naming here is not perfect. So might want to go back and rename this to, for example, wagons. And press accept. And let's go back here. And let's now go into iteration. We're going to say grab the channel. And we want to have our wagon number, which is already here. And we're going to close this off. So now it's number 0, because here they are reset again. So I'm just going to press a couple values in here to work with now. So now I want to create an attribute here, which is called pattern, which then grabs the data of the first one. So the loop will loop 3 times over each one. So each time we do a loop, we get the data from this specific pattern. So we're going to do a create of an attribute. So create attribute. And we just want to get the pattern. So I'm just going to call this pattern. And this is, of course, a string value. Now we also need to get the loop data. And often I would do an extra spare input here, which will be this field. And we're going to grab here this count node. So this will be holding data about the iterations. So we can grab those nodes and we can drag and drop this in here. So now it's linked with each other. So we can get those values and share them. And now we're going to have to type in something special here. So let me make a bit more room. So first I'm going to place a tilde key. And then I'm going to say get a channel reference of the string. Then I would like to actually combine 2 different string values, which we can do with this function. So string get. And then I want to say get the patterns. And now we can see we have pattern 1, 2, 3, but I want to grab pattern without a number. And then I want to close this off here. And then I'm going to type in the number of the iteration. So detail -1 and search for iteration and index 0. And then close this off. So now I have the results. So you can see that we now have filled in BB. So if I go back, BB is actually not the first one. So this is not what I'm currently expecting. So what I actually need to do is I need to add a +1 over here. So the loop will start from 0, and then it goes from 0, 1, 2. But we have the pattern numbers here. So if I go back, and these are just called number 1. So we need to do that +1 because the loop starts from 0. And now we are having the right value. So currently we are looking at the last version of our loop. I can, for example, force my loop to do single passes, and now it will look at the first or the 0 pass of this loop, which is then ABB. So we have that now stored in attributes. So that's our first step, getting that value. Then our next step is I want to create a point for each part that we type. So whenever I type A, B, or C, I want to create points for that. So we'll do with a wrangle. So I'll type a little bit of code here. So we'll make a for loop in here as well. And the way I'm going to do that is I first need to know how long my for loop will be. So I need to get an integer, which is the length of my current pattern. So I'm just going to call this, for example, the count for my loop. And then I'm going to say get the string length of for example, here, the S pattern. So we're just basically now getting value number 3. So we have, because we have 3 parts here. Now we can use this in a loop. So for loop, then we're going to say create integer x, for example, or I. This starts at 0. Then we're going to say that this is for the count. And then we're going to define to add +1 each time. So now we're going to make the logic. So for each time we do a loop, we actually want to add a point. So I'm going to type an int, create new point, which is then representing a function called add point, which will actually add the point. And this point will be stored on mesh 0, which is itself, and with value x. So we're going to close that off. And now we're going to also do a set point attribute. So we created that point, but now we also want to set an attribute on the point. So we want to store something on that newly created point. So we're going to say set point attribute on mesh 0, which is itself. Then we want to call this, for example, part, and we want to store the attribute further on the new point group. Then we want to store the individual part of the string. So the first time this loop goes off, it will store A, second time B, third time also B. So we're going to say here, I'm going to grab the pattern. And now we want to extract a very tiny part of that. So we're going to use these brackets, and we're going to use x as our defining part on what to extract. So we're going to say x and then also x plus 1. So we're going to basically say, like, look at the string, look at x, which can, for example, be 0 at start, and look from 0 to 0 plus 1. So look from 0 to 1 to get the first part. Then we're going to use just setting these values. So let's see if that works. Oh, I mistyped the x here. And now we have these things. So a quick recap here again is we will loop over this pattern, and we will loop the amount of each character in here. So we have A, B, and B. So we want to loop 3 times. And we want to extract those in an individual points here. So only thing left here is that you can see that point 0 is holding nothing. And of course, point 0 is our actual original point. And at the end of our system, we can actually say, I want to remove that point. So remove point. And we're just going to say 0 and then delete itself. So we are removing that original point. So now I have 3 points representing my pattern. This is what I want. So later I might come back and tweak a few things here. But the base logic is this loop here to get that number, to get those characters. Then next up, I want to do now a loop over each point. So now I can grab the point and I can say grab part A. So we can just combine what I have here with my system. So we're going to do a for each loop, so for each point. So we're going to plug it in over here. So we're going to make sure we are grabbing the pieces every merge iteration. So I want to now input this as well. And I can, for example, grab the input here. We can delete this. And instead of the method, we're going to just say input. And we're going to just go like so. So we're inputting that information. So input means that it doesn't necessarily do anything special compared to like fetch piece or point. It will do a few things. Then we also want to create another part here as well. And this one, if I would remove this one will get feedback data. So we are doing multiple loops here, and we are also going to be able to get the feedback. We'll use that in a moment, and it will be clear why that is here. So first thing to do is I want to extract my part. So in here, what can we do, for example, is we can just blast away the things we don't need. So again, I want to blast away from this part, and I need information of this part. So I will do a spare input, and I will connect these nodes with that small line here. So now I can type a logic to define what to delete. So what I will say is look at the attribute, which is called pieces. And then if this is equal, I have to use the tilde key. So if this is equal to the point -1, which is of course looking at that spare input, at 0, so look at point 0, and then grab something which is called the part, which is that attribute we just created, and close that off. So might not work by default. We might have to switch this to points, and we also have to reverse to deletion. So now we are grabbing this single part. So we're just saying, so in this logic here, we're just grabbing the point data from the part. So this is what we are grabbing. So we're grabbing the B. So if I want to double check this, so that indeed worked. So I grab number B. So if I put this here into my output, we will see that we will have the pieces all just stacked onto each other. So I already want to have some form of alignment in here. We can do this by a transform node, so transform. And with this transform, I want to get the data from my feedback actually here. So this feedback node will be able to get data from past iterations. So I want to use that data to then move up my position of my model. So again, I want to grab data from another node, and I just want to go to spare input. I want to link those nodes together. And now I want to translate into a specific direction. So if I look here, I probably want to indeed move here the x-axis. And I'm going to do this, of course, in an automatic way. So I want to grab the bounding box of my feedback. So we're going to use a feature called getBoundingBox. Box. And we want to say from our spare input, which is -1. And then we're going to say the maximum amount, so x max value. So with that, you can see that there is some offsetting here already. So we're now offsetting them a little bit. But of course, we need to also add the bounding box of the object itself. So we're going to have to say plus the bounding box of the current model. So I'm going to close brackets. So bounding box of the object itself. So 0 means looking at itself. And then we're going to say get the size x of this object. And we also want to divide this by 2. And now we're going to move that up. So if I look at the result now, we actually now are properly aligning those models, as you can see, like they're properly aligning themselves. And this is then the first part of my system. So if I now plug this in over here and toggle this off, or maybe I can just visualize this. So as you can see, this is perfectly working. Now, of course, here we are fully like collapsing it into like one single thing. But I will take care of that in the next part. So in this part, it was mainly about extracting the patterns and actually converting this into models. So I can go back to my tool and I can just type in more models. So I can just type in C, I can type in E. So you can just type in more and more models, as you can see. So we can, for example, make this longer and play around with this. So that was it again for this video. So we mainly extracted the parts that we typed in here and actually converted that into a pattern to sort out our models. This is actually some similar logic that the building tool has to subtract patterns into logic for model placement. So in the next part, we're gonna again improve this system what we have here, and we're gonna make sure we actually put a nice terrain out as a result.